everyone. Welcome back to online video tutorial on hydrology and irrigation engineering. In the previous class, we have discussed how to measure the rainfall. So in this class, we are discussing the optimum number of rain gauges. So because the rain gauge is an instrument which is used to measure the rainfall, and we have discussed two types of rain gauges, that is recording and non-recording rain gauges. So today we'll just discuss what is the optimum number of rain gauges to measure the rainfall. So if you take a sampling area of rain gauge, so is small compared to the aerial extent of the storm. See, if your sampling area is nothing but the area, so which includes the record of rain gauge. For example, if you're installing the rain gauge here, so it will record only the precipitation which falls onto this particular area. That is called the sampling area. So whereas, but if you consider the storm, it will occur for a very large extent. So in this, for this particular area, the storm is occurring. But so the rain gauge which you have installed here, for example, in the second figure, so it will record only this area of rainfall. So that is nothing but the sampling area. So compared to the aerial extent of the storm, sampling area is very small. So if you want accurate measurement, see why optimum number of rain gauge station we need required, because so to measure the more accurate rainfall value. So you should know how many number of rain gauges you should be installed in a particular area. For a particular area, how much number of rain gauges you should install to get a accurate result. So for accurate estimate of average depth of rainfall over an area, so it is desirable to have large number of rain gauges. So if you want a more accurate result, then you require large number of gauges. So that is the total catchment area to the total number of gauges should be small. Okay, so the ratio of total catchment area to the total number of rain gauges should be small. And where total catchment area to the total number of rain gauges is defined as the rain gauge density, or it is also called as network density. See, number of gauges should be large, but the rain gauge density, that is nothing but area to the number of gauges, that ratio should be small. So if this is a rain gauge density, obviously if number of rain gauges are more, then the rainfall density is less, because it is inversely proportional. So thus rain gauge density gives an average area served by the each gauge. So, and also on the other hand, an economic and other considerations, such as you have to consider the topography, how the topography is there, and whether there is an accessibility for that area, and is there any restriction the number of gauges to be maintained. So all those things you have to take into consideration while installing the gauges. And hence, for accurate hydrological analysis and for forecasting optimum density of gauges should be adopted. So if you want to do some hydrological analysis and also forecasting, so future forecasting, so you should be having optimum rain gauges. So where WMO, that is World Meteorological Organization, have recommended so some of the rain gauge densities based on the type of region. That is for a flat region of temperature and Mediterranean and tropical zone, so minimum gauge is 1 with an area of 600 to 900 kilometers square. Minimum is 1, so acceptable is also 1, so which is for 900 to 3000 kilometers square. So similarly for mountainous region, so the minimum number of rain gauge is 1 and acceptable is also 1, so where the area is 100 to 250 kilometers square. So for a minimum rain gauge, and so acceptable rain gauge is 1 for an area of 250 to 1000 kilometers square. And similarly for arid region, so 1 gauge for an area of 1500 to 10,000 kilometers square. And in small mountainous islands, so with irregular precipitation, 1 for every 25 kilometers square. So these are some of the rain gauge densities which are provided by WRO. And in this, the 10% of the gauges should be recording type. So to determine the rainfall intensity, so in this, the 10% should be of the recording type of rain gauges. So, and also this density, the rain gauge density will vary from country to country and also from region to region. Okay, so that's why the Indian Standard Institution, that is ISI, have recommended so some other densities based on the region, that is according to the IS 4987/1968. So this ISI have recommended for a plain area, okay, with an area of 520 kilometers square, the recommended is 1 rain gauge, and the region with the average elevation of 1000 meter above the MSL, so with an area of for an area of 260 to 390 kilometers square, the rain gauge is 1, acceptable rain gauge is 1. And immediately for hilly region with a heavy rainfall, with a higher density of an area 130 kilometers square, so the acceptable rain gauge is 1. And in this also, the 10% of the gauges should be a recording type of rain gauges. And the adequate, so adequate number of rain gauges in the existing network, so that is, already there are, for example, if you have a area here, already some 2 rain gauges are there, so along with that 2 existing rain gauges, so how many number of rain gauges you need to install extra, so additional gauges you should install along with these 2 existing, so is determined by the procedure which is given by the Indian standard. So that is optimum number of station is given by N is equal to CV divided by, so epsilon whole square. So where epsilon is the allowable degree of error in estimating the average depth of rainfall, and CV is the coefficient of variation of rainfall recorded at M existing rain gauge station. So CV is the coefficient of variation. So that is both are in terms of percentage. And here, so CV is calculated. So this is a N. So first N is calculated using CV divided by epsilon. So CV is calculated using 100 into sigma m minus 1 divided by P bar, where P bar is the mean precipitation. So you know that summation of Pi divided by M. So where Pi is the precipitation, depth of precipitation in ith station. It may be 2 station or 3 stations. So the summation of Pi, summation of 1 to M into P of Pi divided by M. So that is the mean precipitation, and sigma m minus 1 is the standard deviation. So you know that it is square root of summation of I to 1 Pi minus P bar whole square divided by M minus 1. So this is how, so this is the equation to calculate the coefficient of variation. So that is, if there are M stations in the catchment, okay, so each recording rainfall values of P1 to PM. Okay, so P1, P2, PM are the rainfall values. So where M is the number of stations. So the CV is calculated using 100 into sigma m minus 1 divided by P bar. So where P bar is the mean rainfall or mean precipitation, and sigma m minus 1 is the standard deviation. So sigma m minus 1 formula is, so square root of summation of 1 to M Pi minus P bar whole square by M minus 1, and Pi is the precipitation in ith station. And while calculating this coefficient of variation, the error, that is epsilon error, is usually taken as 10%. And if you can see from this formula, if epsilon, the error is less, obviously the number of rain gauges will be higher, because again it is inversely proportional. So if the error is small, then N will be more. That is how you're going to calculate optimum number of rain gauges. Thank you all. We'll continue in the next class.